Manual transmissions are rare in new consumer cars, but millions of units still exist in older cars, commercial, and racing applications. For this video, we've chosen a front-wheel drive arrangement. Our transmission model is a constant mesh type design where gear sets are always in contact with each other. Let's start with the clutch. The clutch assembly is securely attached to the flywheel, which is bolted to the engine. It's always spinning if the car is running. The components inside this assembly allow power flow to be disconnected from the transmission input shaft. Note that the transmission input shaft does not itself connect to the engine crankshaft or flywheel. Connection to engine power is accomplished with a sliding friction disc, sometimes called a clutch plate, sandwiched between the flywheel surface and a movable pressure disc. The clutch plate assembly is splined to the transmission input shaft, but can slide back and forth. The pressure disc gradually squeezes everything together as the driver releases the clutch pedal for a smooth connection to engine power. To further ensure smooth power delivery, the clutch plate has a built-in damping system. The friction plate floats on the transmission input shaft. Power flows from the disc through damping springs which push against a rotating top plate whose center is splined to the transmission input shaft. The springs continuously absorb vibrations or other potentially harmful anomalies in the flow of power. Now let's look at how the pressure plate moves. The pressure plate is connected to a special diaphragm spring. This strong spring is what naturally presses the pressure plate to the flywheel. The outer cover has hooks that hold the diaphragm spring securely in place and act as a fulcrum. There are also supporting leaf springs attached to the pressure plate and cover. The clutch fork sits at the center of the diaphragm spring. As the clutch fork pivots, it presses against a release or throw-out bearing, depressing the diaphragm spring's inner prongs, which in turn lifts its outer edge and the connected pressure plate. Let's see that movement a few more times. The clutch fork acts as a lever with a fulcrum point on the transmission case interior surface. It's driven by a hydraulic actuator whose lines lead back to the clutch pedal with its own hydraulic actuator and fluid reservoir. The gears. Each speed has a gear set so that input speed can be different from output speed. The speed gears in this constant mesh transmission are always linked. They have diagonal or helical cut teeth for quieter operation. Notice the reverse gear set with its straight teeth. This transmission will make a familiar gear whining sound when in reverse. Engine power flows through the main shaft, to the counter shaft, to the differential assembly, and out through front axles. Synchronizing gears. To make gear shifting possible, one gear in each set floats freely on its shaft, riding on a roller bearing. The other gear in each set is either connected with splines or directly machined into its respective shaft. For power output, the floating gear in each set must become securely connected to the shaft through the synchronization process. Between each gear set, there's a synchronizer hub that's splined to and rotates with the shaft. A A sliding shift sleeve is also driven by this hub, which can be moved back and forth by a selector fork. Forks are connected to sliding rods that are held by the external casing. During gear selection, the fork moves the sleeve towards the desired gear. A blocker ring sits between the sleeve and the gear. The blocker ring's job is to get everything spinning at the same speed and lined up for a synchronization attempt, or block further movement if synchronization isn't possible for whatever reason. The hub has slots for 3 synchronizer keys that spin the blocker ring, but allow enough play so the blocker ring can adjust on the fly as the sleeve teeth approach. The shift sleeve's internal teeth are shaped to push against the keys, which in turn press the blocker ring against the gear. The ring's inside surface is conical and has ridges to engage the cone-shaped gear surface like a miniature clutch. Gradually, the gear begins to spin with the blocker ring. The keys are spring-loaded. Once enough pressing force builds, the keys are no longer needed and move down and out of the way, allowing the sleeve to progress into its final synchronized position with gear locking teeth. This process enables fast gear selection between rotating components while keeping main gear teeth safe from the change procedure. Locking teeth on the sleeve and gear are slightly angled in some designs, encouraging a more secure connection. Now, power flows through the splined hub and sleeve, through the gear set and out of the transmission. To switch gears, the clutch is pressed in, pressure is relieved, and the sleeve can slide into synchronization with an adjacent floating gear. Since each sleeve can only slide between adjacent gears, for this 6-speed transmission there are 3 selector forks and rods. The first and second floating gears operate from the output shaft, but this doesn't fundamentally change functionality in any way. Forks and rods only move back and forth, as directed by the shift change assembly. This component can swing side to side to select a specific rod and fork. And once selected, a metal tab pushes the fork one way or the other. Let's trace this component's movement from the shift lever itself. The shift lever rides on a ball that allows movement on 2 axes. Each movement axis is separated into its own cable. These work something like bicycle brake cables to translate stick movement to the transmission. At the other end, cables are attached to a rod that protrudes out of the transmission case. This rod can move up and down or rotate based on distinct cable input. A specially designed piece at the other end of this rod moves connected components to swing side to side or slide the metal tab back and forth. Reverse gear. The reverse gear has its own rod and selector fork. The transmission must come to a complete stop to shift into reverse as there are no synchronization components. Adding the third idler gear to the system reverses final output. Neutral. When in the neutral position with no gears selected and the clutch engaged, meaning the clutch pedal is not pressed in, the transmission input shaft spins, but since no gear is synchronized, no power flows out of the transmission. Oil. Oil rests at the bottom of the case and is splashed up onto gears for lubrication. There's no oil pump or filter.